Hey everyone, if you are enjoying these videos, go check out my website at www.apcsexamprep.com. I have information on boot camps and tutoring availability, along with other AP Computer Science resources I think you'd enjoy. Hello and welcome to 1.11 of CodeHS's AP CSA 2025 edition. Today we're going to be talking about the math class. So if you remember, we just got finished talking about class methods, and this feeds right into the math class. Class methods are methods that belong to the class itself and can be called without creating an instance object of the class. And so you would use this static keyword, and then you would just have to do calculator dot add numbers. You wouldn't have to create a calculator object. So it would look something like this. And so in Java, the java.lang package is automatically imported in, and so we have access to the string class, math class, system class, and runtime class. Versus the java.util package is one that we have to import in if we're trying to get scanners or some of these other classes. And so Java's math class contains built-in methods and constants for performing basic math functions like finding maximum values, square roots, and powers without needing to write code yourself. So we're going to be borrowing code from the math class, and it's nice, just like we talked about in the last section, it allows us to store all of these functions in a contained place and keep organized, and we don't have to create a math object in order to call these because they are all static methods in the math class. The class is available by default and therefore doesn't need to be imported like I mentioned before. And so this is how we are going to call all of these static methods. We use the class name, dot, and then the method. And so you can do things like get the absolute value, power, we would put parameters of a base and then the exponent to the power of what, and then math.sqrt and Math.random. So the first three are pretty self-explanatory, pretty easy, and we'll go pretty quickly through those. And then the Math.random is one you want to spend a little bit more time on if you're not familiar with. So we'll do that. And so Math.absolute changes -5 to +5. If it was a positive number, it would stay positive, right? And so it works with int values or doubles and returns the same type that was plugged into the parameter. The method definition is overloaded in order to accept and return integer or a double. So Math.pow, we have the base value and then the exponent, so the order matters. So 2 to the power of 3, so 2 cubed is 8. So it's equivalent to 2 times 2 times 2. So you can do 2 to the power of 8, and that would avoid you from having to, times 2 8 times and count that and make sure it's the right number of times. And if it was bigger than that, 2 to the power of 30, that would be increasingly difficult to write out. So we have math.sqrt returns the positive square root of x. So just as it says, you plug it in, and this will always return a double. And so, yeah, that would be our answer. And then Math.random. So returns a double value greater than or equal to 0.0 and less than 1.0. So Math.random returns a random double value greater than 0, less than 1. It does not take any parameters. And so you would have to manually create a way to get a range of random values. And we'll talk about that here in a second. So rand will be a different value every time the code is run. And so it could be 0.7434, it could be 0.3939, it could be 0.1396, any value between 0 and 0.9 repeating. So when and why would you need to use random numbers? For games, simulation, cybersecurity, and cryptography, and anywhere you need some level of unpredictability. So why is it 0 to 0.9999 and not just 1? Well, we're going to manipulate this value to allow us to get a range of int values, and we want an equal opportunity for this to be a 0.0, 0.1, 0.2, all the way up to 0.9. If there was a very unlikely but a random chance that it could actually land on 1.0, the way we manipulate it would give you an extra value that would be very unlikely to land on, but could possibly be landed on. the way we manipulate it, we want to have an equal opportunity to land on a random int value. And so how do we get a random value with this random decimal of 1 to 6? Well, we would need to multiply it and then cast it to an int value. So here we have an example of values 0 to 9. You multiply it by 10. So let's say we get 0.534. We multiply that by 10. It's 5.34. And then we cast that value to an int of 5. And there we have our random value. And if it's 0.999 repeating, we times that by 10, that becomes 9.99 repeating, cast it to an int, and then it turns into just 9. And so you see with a variety of examples of random numbers how that gets cast to different int values. And so you have an equal chance of landing on this 0.9 as you do 0.0, 0.2, 0.1, 0.7. Because then we multiply it by 10 and then we cast it to an int. So how do we get a value not 0 to whatever your range is, but wanting to change it maybe 1 to 6 like we said with the dice, or an even higher value of like 10 to 20. So that's what we'll do the example of here in a second. So this num values is our range essentially. So if this was just times by 10, the offset wasn't even used on the last one. Then we cast it to an int. 0 to 9 is 10 separate values. So that's what that value, that variable will represent. Whatever is plugged in there will be the number of values within the range. And then this offset is your starting point of the range, but that obviously will also affect the ending point of your range. So this plus will happen after all of the rest of this, the random, the multiplication, and the int. Then we'll add the offset to push our starting and ending value to a greater number. So if we create a random integer between 10 and 20 inclusive, that is 11 values. Ignore what the starting and ending is. That's how many values. What's our range? 11 different values. And then we add 10 to that because this would get a random value 0 to 10 before we add 10 to it. So then if we add 10 to that, whatever the range 0 to 10 becomes 10 more on the minimum and the maximum. So that 0 to 10 becomes 10 to 20. Okay. So this is it working in action. Random value 7.38. You times that by 11. That becomes 8.12. Cast that to an int. Then you add 10. You get 18. Okay. So working in here, which of the following best describes the purpose of the math class in Java, used to store a user-defined formulas and perform custom operations? So it's not user-defined formulas. It provides pre-made methods for performing common mathematical calculations. It manages the creation and storage of numerical data types. No. It provides a scientific calculator interface. No. So that would be our answer. Which of these is an example of calling the absolute value method in the math class? Math.absolute. What range of numbers would be generated by using Math.random times 501? So that would be 0 to 500, which would be 501 different values. And there's no offset, so that's how you know it starts at 0. What would the program print? So square root of 64 is 8. 3 to the power of 2 is 9. Absolute value of 8 minus 9 would be -1, but the absolute value would be +1. So then we have positive 1.0. Okay. All right, so exploring the math class API. Math class contains many more methods that can aid you in your program's math-related calculation. So if we take a look at the math class, choose 4 new methods from the list and use them in the program in the same way the current ones are used. So use the math method, storing the result in a variable, print the value of the variable with a string that describes what the method is doing. So they want 4 new math class methods. Okay, so here's a list of our math class methods. Let's do seal for sealing. That rounds up. It returns a double, but the value of an int. So I would do double round up equals math.seal of 3.2. So we can test this. And it rounds up to 4.0. Double round down equals math.floor of 9.9. Round down. For math.floor. And then we can do max and min. Double max equals math.max of 5.4 and 6.7. Double min equals math.min 3.2, 1.1. Those all work. And check our code and we're good. Okay. Setting the random range. So we're going to create a random integer within a specified range that can be tricky. So 6 and 20. Print a random roll of the dice. Print a random integer 10 to 30. Okay, so we're going to use Math.random a few times here, which is great. This is the example, but let's go to comments. Tell us what we need to do. So int random roll equals Math.random times the range is 6 plus 1. And 30. I'm going to reinvent the wheel here. I'm going to have to make a lot of changes to the name, random, range. So it's going to be 21 different values because it's 10 to 30 inclusive. And then this is going to be random range. Int print a random 0 or 1. Random 0 or 1 equals int math.random times 2. And since it's 0 or 1, that's a range of 2. And cast to an int, this would be, 0 to 1.9 repeating when we times it by 2. So then we print random 0 or 1, and then int random large equals int math.random times 1,000,000, 1, 2, 3, 4, 5, 6, about 1,000,001 because it's exclusive, so exclusive plus 1, 2, 3, 4, 5, 6 system.out print line random large. Now you guys can choose your own. So they're saying that we should use 999,999, and then our min value is 101. So it's exclusive of both of those values, not just the max value. I was looking at exclusive for the 2 million. And so that's what we're looking for. Okay. Geometry class, get circle area, get sphere volume. To do this, you'll do the following formula. So we're just doing math formulas here. So we'll look at this. So area of a circle is radius 5. We call geometry.getCircleArea. That must be a static method. So we need to write out this static method of get the area of a circle. So we would return pi r squared, math times pi squared. So we could do practice our math methods of Math.pow pi, comma 2 times radius. You could also do Math.pi times Math.pi, and then get sphere volume. Okay, so we would do return Math.pi times 4.0 divided by 3, so we don't do integer division, times radius cubed, Math.pow, radius to the third. So then in the runner, they want us to print, are there any errors? No. So we check our code. Oh, so we would do, whoops, got the formula wrong. We want to do radius squared times Math.pi, and then 4/3 times pi times radius cubed. It looks like the volume one was correct. It was just the area of a circle that was incorrect. And there we go. Okay, imagine the following scenario. Traffic engineers are designing a timing of a stoplight that allows a single car to merge onto a highway. The car starts from rest, then accelerates at a constant rate over the distance d of the on-ramp as pictured above. Okay, so we need to get the distance, get user input for the distance. So we'll work on the rest of it in a second. So input, new scanner, system.in. Do they have a prompt? Enter the on-ramp distance. And then we would get a int value, it looks like. Yeah, int dit. Okay, calculate the time to accelerate down the on-ramp. So we need to use this method, calculate time, and then we need to call it. So first, we are going to need to calculate time. So return math.square root of 2 times distance divided by acceleration. And those are double values. And so that should work as it should. But we need to calculate the value for acceleration. We have the distance plugged in. Okay, so assuming the average car acceleration is 3 meters per second. So int accel is going to equal 3. Those get converted to doubles when they're plugged in. we can system.out.print line calculate time. I should probably store this in a variable so that I could potentially use this again, but Excel, comma, distance, and then utilize that in the formula. And I'm going to go straight to checking the code because I don't know. I guess I could have plugged in 600. Looks like on line 12, got a semicolon. And I'll go back and run it if I need to. But it looks good. And that is it for 1.11, working on the math class. I hope you enjoyed the video, and let me know if you have any questions. I hope you enjoyed the video, and don't forget to check out my website, apcsexamprep.com, where you can get more information on boot camps and tutoring availability.